separately. Good afternoon, everybody, and welcome to the final split session at AusCert 2022. My name is Valdemar Jacobson from Business Aspect, and I will be your chair for this session. This last session, we have Mandy Scott from Fastly talking about the WAF efficiency framework, well, introducing it and discussing true or false positives. So please welcome Mandy.
Thank you. Thank you. Hello, everybody. My name is Mandy Scott, and I am the staff sales engineer for the ANZ region for Fastly. Today, I'm going to be presenting a framework which measures the efficacy of your WAF. This is not my research. This is the work of our amazing research team in the US. It's an open source project, so I will share the details afterwards. There's a GitHub library that you can use if you like. Oh, sorry, I've got to use this one, don't I? Maybe not. I think now, because I'm on different.
Well, if you're running it completely, you'll probably just have to go over to the other display and go forward.
Okay.
Like that.
Yeah, okay, cool. Apologies, everybody, about that. So quickly, if any of you are not familiar with what a WAF is, it's basically a protection mechanism. It's there to inspect all the HTTP traffic coming into an endpoint on the internet, such as a web application. And it has the purpose of blocking any malicious traffic or otherwise alerting so that you can do something about if there's an attack there. Why would you want to test it? Well, specifically, a number of reasons, I guess. Continuous verification that the WAF is doing what it's saying it's doing, detecting new and updated threats, overcoming bypasses, benchmarking, and also getting some measurements for comparison in future and feedback and continuous improvement. So quickly, a little definition on efficacy versus efficiency, because when the team first presented this, I have to admit I was not clear on the exact difference between the two, but it's relatively straightforward. So effectiveness or efficacy is a quantitative measure. So is something doing what it's supposed to, or what it says it does? Efficiency is, however, a qualitative measure. Is how well is something doing what it says it does? So this is Calvin and Hobbes, and Calvin's being very focusing on being effective, whereas Susie's focusing on efficiency there. So yeah, I had a little story that I wanted to tell you about yesterday when I got to my hotel room and I popped my laptop into the safe, as you do, just so it's not out on the desk when the housekeeping comes and everything, and I didn't need it all day, so I popped it in the safe, popped in my code, went on my merry way. When I came back in the evening after the conference, the code didn't work, and so it was very effective in protecting my laptop because I couldn't get in, but it wasn't very efficient in letting me get into it. I had to call the hotel duty manager, and it was actually a low battery that was the issue. But anyway, so there's another example for you. Sorry, it's hard to tell where my mouse is. Cool, so let's go have a look at the approach of the framework itself. So in the context of a request, you've got your URL parameters, your domain, your body, your headers, your cookies, and attackers pretty much are always looking at places they can put things in those to stage an attack. So for many of these cases, it's just injecting the payloads in different positions. So one popular example is to encode a payload inside that bypasses the detection because it's not unencoding or decoding that payload. So we do a bunch of tests that check for different evasion tactics. The purpose of this is so that you have a baseline, and then you can, baseline for comparison, and then you can configure the WAF based on that. So for these tests, we configure it with out-of-the-box rules, and it's configured in blocking mode. And it doesn't have to be a Fastly specific WAF. It can be used on any WAF that you might like to test it out on. So to make it all reproducible and reusable, we've used a flexible framework called Nuclei. So they're YAML templates, and they let you define absolutely everything that you're sending through to the requests. In order to determine whether a test is successful or not, we look specifically for a 406 not acceptable response, meaning that the request was blocked. So most WAF solutions should support doing custom response codes for blocked requests. We have some documentation on the Fastly site if you're interested. If yours doesn't do that, maybe time to reconsider the investment, but anyway, onward and upward. So the workflow, we have two different test cases. We test true positives and false positives. So a true positive ascertains whether the payloads are correctly identified, and a false positive ascertains whether acceptable payloads are actually misidentified or incorrectly identified. So this is an example of a Nuclei template. It's just YAML file. This is a SQLi or SQL injection template, and you specify the actual payloads inside a little file that you point to. Whoops. And then we've also got some details on so this just shows you an example of how the raw and encoded versions are sent in the payloads as well. So you might be wondering about where the payloads come from. So for the GitHub framework that you'll see at the end, the link that I'll share, that one specifically is a basic setup that you can use to base your tests on. But we generally use these sources, so Payloads All the Things and Portswigger, and we do our own research too, so that's courtesy of the team in the US. So in the interests of continuous improvement, you need that feedback loop. So they set up a weekly sort of automation. It essentially releases a build, after the build each week, it kicks off an excuse me, I'm rushing. It kicks off a weekly efficacy assessment. Then once that's done, it sends those results through to the Google Cloud, and then that goes through to BigQuery. And then finally, that goes through to, a dashboard so that we can have fancy reports and not have to interpret numbers. So let's have a look at a sample result. So this is an example test result. It's it backs the dashboard that you just saw. It's all in logged in JSON format, and it includes the request, the response pairs, and some additional metadata. So next thing, we'll go through how do you calculate the efficacy score. Well, you want to find the balance between false positives and false negatives. In practice, every security tool has false positives and false negatives. I'm sure you're all aware of this. Otherwise, security would be a solved problem. So there's no infallible protection other than just blocking every single request, which is not ideal. So to account for the disparity between the two outcomes, we calculate the efficacy scores based on a metric called balanced accuracy. You might have also heard of it called a confusion matrix. It's a good measure when you're seeing the imbalance between different classes. So in this case, between correctly identifying negative and positive cases. The two metrics are sensitivity and specificity. So they're listed out there for you to have a look at. So sensitivity is the true positive rate, and specificity is the false positive rate. Then you take the arithmetic mean of the two. to get the balanced accuracy. So as an example, we've got 70, say that we have data that came up with these percentages after we ran our test. So we've got 76 signalled as true positives and 24% of them as false, and then 1% of them as false positives and 99% as true negatives. So we do add up the true positives and the true negatives and take the average of those to get 87.5%. So the higher the false positive rate, the lower the risk of an attack, but at the same time, legitimate traffic will potentially get through, incorrectly identified, and it'll be exacerbated in blocking mode. So on the other side, though, a higher false negative rate lowers the chance of false positives, and that means high fidelity alerts, but there's a high chance that you won't actually detect attack traffic, which is not what you want. Now, I had planned to show you a demo. However, given the troubles I've had getting my slides up here, I'm not going to do that, I'm afraid, which cuts my talk a little short, but never mind. I will point you to the GitHub library is here. So in the Fastly, you can search the Fastly repositories and you can find it there called WAF Efficacy. And if you have any questions, I'm happy to take them now, or you can email me, mandy@fastly.com. And yeah, thank you for your time.
Let's see if we have any other questions. Okay, so there isn't any questions specifically from the audience, but I'm kind of curious, how's this actually being used? Are actually anybody outside of Fastly using it to assess their own capability yet? Is Fastly using it broadly internally, or is it currently just proposed?
Yeah, so it's quite new. The team's only just presented it to us recently, a couple of months now. But yeah, Fastly uses it, so the daily or weekly build, and then using that to assess what changes need to be made in the weekly agent build. But yeah, other than that, I'm not aware of anyone else using it outside of Fastly.
Okay, and is this currently, or has this already been made available publicly other than through this presentation?
It is already on GitHub.
Okay, good.
But I'm not sure that it's been spoken about yet.
Okay,
Yeah.
great. And is it easier than using ModSec? Mod security?
Well, that depends on your WAF, I guess. If your WAF uses ModSec, then you're kind of stuck with it.
It also depends on how much you want to operate, tune, and get into the weeds into your own infrastructure versus outsource it to somebody else to actually do for you, like Fastly or any of the other CDNs that provide these kind of capabilities.
Yeah, the services, or choose a WAF that uses a non-ModSec approach, which is the Fastly WAF. Sorry.
And a question that's not quite a question, and does it work with it? Not quite sure I follow what it's trying to... Does it work with mod security, I suppose, is what they're trying to suggest as a follow-on?
You can point it to a WAF endpoint and run these tests. The nuclei templates are just YAML, so you can configure it to...
Right, so in other words, you can run it against almost anything where you're actually getting output that says allow, deny. Yeah,
as long as you can have a 406 blocked response. Yep.
Good question, actually. Does it work out of the box, or does it need a lot of analysis and customization to get it working?
It'll work out of the box in terms of a very basic setup for the templates. So you'll see that in the library. They're pretty basic, but it gets you started. And then, yes, you can do a bit more research beyond that if you want to be specific.
I guess it's like anything like this. You actually want to tune it to your own requirements. But this is kind of to the point, trying to actually make it so that you can actually see where you need to actually tune the security capability that this is actually giving you the feedback on.
Yeah.
So it's kind of a good feedback loop, I suppose.
Yeah, that's the idea.
Which, KPIs, measurement, actually response to proving capability or life cycle of a capability. So, yeah. Okay, well, I guess we can probably call it there and let everybody go to afternoon tea early. There is one more. Okay. Okay. Yeah, I'll repeat it so that people who are listening remotely can actually follow along.
Any baselines against the two big other biggies, F5 and Verba? Like how we still plays with it as a baseline if you're basing results?
So, if I understand the question was around, are there any baselines for comparison against the other big capability providers in this space, F5 and Imperva?
The short answer is no. So, yeah.
I'm sure there possibly will be over
Yes,
time,
there
depending
will
on
be.
who's choosing to use and implement it and what information they're going to share, or whether a third-party project steps up and actually tries to do comparisons and use this tool to actually compare the people who originally proposed it and made it and all the other people in the space, which would actually not be a bad idea for a bit of an open source, open assessment project. Okay, well, I guess we'll call it there. On behalf of the conference, thank you very much.
Thank you. Thank you.
So now we've actually got a little bit of an early afternoon tea break. Go have afternoon tea and come along to the speed debate once they've actually put the room back together. And after that, there's going to be the conference close and the drawing of all of the different prizes and what have you. So thank you. Thank you. So you applied this yourself?
Yes, I
Oh,
did.
very nice.